Hi everyone. So instead of being in my basement, today we are in my kitchen. My husband and son are in the basement, so you can see nice mirror. Oh, I should use this hand. A nice mirrored wall on this side, our shiplap wall over there. So I apologize if you hear my dog barking because the front door is right over there and I can't guarantee anything. So hi, welcome to activity 5. So we're going to go through the activity just like we have been in the other videos, but as always, here's what I'm going to ask. Split screen, so the assignment, one side of the screen, my face, this video, on the other side of the screen. You're going to follow along with me, pause when you need to pause, and we're going to have a really good science lesson. So, new school activity 5 says, today we'll continue on with the lesson we began in activity 4. So, what we did before with the flying balloon, we're going to build on that today. Please ensure you are watching the teacher-created video, right here, to guide you through this assignment. As always, please answer the questions after the question mark in a color other than black. And please, 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 please use complete sentences, okay? I really appreciate that. So what will we do? This is going to be familiar. You saw this before. We will observe devices to figure out what forces are, 1, acting between the components, and 2, influencing how the apparatus moves. The devices will be viewed over 2 activities. This is that second activity. So go back to activity 1 for a second in your brain and think about, we talked about forces and we talked about components. So components and forces are going to come back full force in this activity. And we said components were just those parts, those small parts of the bigger picture. We're going to be dealing with some components again today, a little bit different scaled up. So question 1 says, what is magnetic force? I don't expect you to know what magnetic force is right now. I expect you to have an idea and maybe some understanding because you've messed with magnets or you did some of those supplemental activities that we had during March and the beginning of April. But I don't expect you to know that. So to kind of get your brain thinking on magnetic force, there's a link right there to a YouTube video. You're going to pause this video. You're going to go to that YouTube link. I know the video was lame. I put it right in the assignment. I said, the video is lame, but it does an excellent job of explaining magnetism. So go ahead, pause me now, watch that video, and then come back. Okay. So hopefully you went and watched the magnetism video, you're back, and you're ready to get into where it says number 2, floating magnets. Watch the video before attempting to answer the questions. So when you click on video 1, you're going to see a video that's going to have some magnets, and the magnets are going to be doing some crazy things. Go watch the video, come back, and then we can talk about everything that you saw. So pause. Okay, welcome back. So, that video. You just watched a video on magnetism, and then you see this device with these magnets, and they're kind of doing some crazy different things, right? Magnetism. We know that magnets can attract, and they can be repulsive. They can push away from one another as well. And that depends on which way the poles are facing. So north and north, the 2 poles are going to be repulsive from each other. Now, we don't really worry too much about the poles or anything like that in this unit. We really are focusing on the forces. So we know that magnets have the force of being able to attract something and push away something. And in this unit already, we've talked about that magnetic attraction. And that was in activity 1 with the magnetic cannon, where that steel ball was rolling in. It was attracted to the magnet, and that's what got the cannon process started. So we have a little bit of an understanding of that attractive force, but that repulsive force might be a little bit new to us. So in the video, we see that repulsive force is going full steam ahead. You've got the magnets that are being stacked on top of one another, but it looks like they're floating. They're not actually touching each other. And the reason they're not touching each other is because of that repulsive force. So let's look at question number 2. Question number 2 says, which components of the apparatus affect its motion? Construct a model of the apparatus that shows these components. Draw this model on a piece of paper, and if you have the means to do so, take a picture of your model. You're going to upload the picture of your model to Google Classroom. So, what components do we have that are affecting its motion? Your model right now for question number 2, you should immediately be thinking, all right, you've got that base, and that base held up that pole that was that aluminum pole. So those are 2 components that we have so far that you're going to draw into that model that are going to affect the motion of the magnets. Then we have those ring magnets. And in the video, I believe they used 4 of them. In my model that I drew, I only drew 2 because that got my point across. But you're going to have those ring magnets as well. So for question 2, the components are going to be those things we just talked about. You've got the base. You've got the aluminum pole. You've got the ring magnets themselves. You may even want to throw in, some people said a component is the person actually putting the ring magnet on. That is a little bit more specific than you need to be right now, but I've had some people say that before, and I understand where they're coming from. So what's affecting its motion? The only thing that's really moving in this are those magnets themselves. So if we're answering question number 2, and we're drawing our model, and we're writing out our complete sentence answer, the components are going to be the base, the aluminum tube, and the ring magnets. But what actually affects the motion? The motion is really going to be affected by the interaction between the magnets themselves. And if you draw a picture, that's awesome. Please upload it. Question 3. If you need more time on question 2, pause, go back to it, and then you can come to question 3 with us. So question 3 says, what are the forces acting on the components of the apparatus that influence its motion? Add these forces to your model. And again, this stuff can get a little bit tricky, guys. So I'm going to do my best to show you through what I'm saying and just kind of work with me, okay? I'm not an artist by any means. So here's the model that I drew. So in the model that I drew, we have our base, okay? So here's our base, and I wrote base on it. And then we have the pole where the ring magnets are going on top of. And then I have 2 magnets drawn on here. And when the magnets are not moving, that's because we have balanced forces. When the magnets are not moving, we have balanced forces. And I'm going to give you an example of balanced forces right now. So this is one of the Sharpies that I was using to draw my model. So here's the Sharpie. If I let this Sharpie go, it's going to fall. And the reason it's going to fall is because the force of gravity is acting on it, and there's no force here to push back on the force of gravity. So if I let go, it falls to the table. It's an unbalanced force. If you go back to our last activity with the balloon, we had unbalanced forces. We had the force of the air on the front of the balloon, and when the force of the air went on the back of the balloon, there was no balloon there. There was a hole. It wasn't tied, so the air would escape. That's what caused the motion. It was that unbalanced force. Balanced forces exist when the amount pushing in one direction, or the force coming towards something in one direction, is equal to the force coming towards that object in another direction. So we have balanced forces. It causes something to not move. In this example, when the ring magnets are staying stationary along the pole that is there, the tube, the pole, I keep messing up my words with that. But when the ring magnets are staying stationary there, that's because we have balanced forces. The force of gravity pushing down on the magnets is equal to the force of the repulsion from the magnet that is below it, or the base, in the case of the first magnet. So let's look, it's upside down. So let's look back at this picture. You've got your base, you've got your magnets. Right now they're not moving. And I tried to kind of draw in with my arrows. The reason they're not moving is because the force of gravity that's pushing down on the magnet is equal, it's balanced to the force of the magnetic repulsion from the magnet below it. So when question 3 asks you, what are the forces acting on the components of the apparatus that influence its motion? You've got a balanced force between the force of gravity and the force of the magnet. It's balanced. There's no motion. When motion occurs at the end of the video, when the person pushes all the magnets down and lets go, that repulsion force that's building between the magnets is greater than the force of gravity. That's why that magnet is able to go off the top. It's unbalanced. So we have 2 major forces here working. The repulsion of the magnet and the force of gravity. They're working opposite of each other. One is pushing up, one is pushing down on the magnet, and that causes the magnet to stay stationary. It causes there to be a change in the motion. That's a long explanation for question 3. But for question 3, we're talking about opposing forces, pushing down and pushing up, that are balanced, which results in no movement of the magnet. And that takes us to question 4. How does the apparatus work? Apparatus is a big word for this base, this tube, these magnets. How does all this together work to create this floating magnet? To go through that question briefly, the apparatus works because we have balanced forces. We have a balanced force of the magnet repulsion compared to the force of gravity. They're pushing against each other, one pushing down, one pushing up, or the forces are acting against each other. Push is kind of a general term. I like the word acting better, but I think right now we understand the concept of push and pull, which is why I'm using those words. So for question 4, I'm looking for a brief explanation, incomplete sentences to kind of summarize everything that we just went through this video. So quick summary of what's happening. You're going to watch the first video on magnetism. You're going to watch the second video on the floating magnets. You're going to try to draw a model. If you can submit it to me, great. I would really appreciate it. If not, you can just answer the questions. You're going to draw that model, the components. You're going to draw in those forces to show how the magnets are stationary or moving. And then you're going to explain how the apparatus works. Have a great day, guys. Email me with any questions.